Okay, get this. What if AI had a brain that could actually learn and get better all on its own? It sounds like science fiction, right? Well, some fascinating new research proposes exactly that, a huge leap forward for artificial intelligence. And that's what we're going to dive into right now. Look, we all use these incredibly powerful large language models, or LLMs, every single day. They write our code, they draft our emails, they can answer just about any question we throw at them. But here's the real question. Are they actually learning from all this? The short answer is kinda no. And that one limitation is exactly what this new research is designed to fix. And that gets us to the heart of the problem, a fundamental weakness in even our most advanced AI systems. It's this invisible ceiling that's seriously holding them back from what they could become. I want you to think of an LLM as a supercomputer that's read the entire internet. I mean, it's absolutely brilliant, but its knowledge is completely frozen in time. The researchers point out that these models rely on what they call static prompts. That just means they can't adapt to new information or learn from experience. In a very real sense, they're stuck. So this sets up a really clear contrast. On one hand, you have the current LLMs, which are kind of like a super powerful calculator. You give it an input, it gives you an output. That's it. But what we really want is an adaptive agent, something more like a learning scientist, an AI that's constantly running experiments, tweaking its strategies, and actually getting smarter over time. So how do you do that? How do you turn a static calculator into a learning scientist? Well, this is where it gets really cool. The research proposes a pretty groundbreaking solution. You give the AI a brain. Now, the technical name for this brain is active inference. You can think of it as this cognitive layer that sits on top of the LLM. Its job isn't to answer your question directly. No, its job is to figure out the best possible way to get the answer. It learns which prompts work, which search strategies are gold, and it does all this by constantly trying to make sense of its world and reduce its own confusion. Okay, but how does an AI brain like this actually think? Well, it all boils down to a surprisingly simple and really powerful idea. The one thing driving this entire system is the goal to minimize surprise. To put it simply, the AI agent is always trying to make the world as predictable as it can. So every time something unexpected happens, like say a prompt gives a terrible result, that's a surprise. The agent's entire motivation is to then update its internal map of the world to make sure that surprise is less likely to happen again. And this all happens in this continuous, nonstop learning loop. So first, the agent predicts what it thinks will happen if it tries a new prompt or a web search. Then it acts, choosing the option it believes will be most useful. After that, it observes the result. Was it good? Was it accurate? Was it relevant? And finally, the most important part, it updates its own internal model. And this cycle just repeats over and over and over, constantly getting smarter. Now, inside that learning loop, the agent is constantly doing this really critical balancing act. On one side, you have exploration. That's all about trying new things to learn more, even if they might fail. On the other side, you have exploitation, which is about using the strategies it already knows work well to get the best result right now. This active inference brain is what allows the AI to intelligently juggle these two competing needs. Okay, this all sounds great in theory, right? But does it actually work? Well, the paper gives us some pretty compelling proof that this agent can genuinely learn, right, from scratch. So this is where the agent starts. And when I say from scratch, I mean it. The researchers say the agent begins with literally no knowledge at all. Its internal maps, the things that represent its understanding of what works, are a complete blank slate. It has absolutely no idea which actions lead to good outcomes and which ones are dead ends. But then, after running through countless learning loops, a clear structure starts to emerge from the chaos. The agent's internal maps are no longer just random noise. The paper highlights that these new patterns show it has learned meaningful relationships. In other words, it has built its very own strategic guide for how to get the best results. And we can actually see its strategy changing over time. In the beginning, in its early phase, it's all about broad information search, just exploring and trying to learn as much as possible. But later on, its behavior totally shifts. It starts using highly targeted prompts, exploiting the knowledge it's already gained. That shift, right there, that's the proof. That's a clear sign of intelligent, adaptive learning. An AI that learns to write better prompts for itself is pretty cool, but this goes so much deeper than that. So let's zoom out. What's the bigger picture here? Why is this such a potential breakthrough? The thing is, this is way more than just a clever trick. It represents a fundamental shift away from thinking of AI as just a static tool and towards seeing it as a dynamic, self-improving system. This research really paves the way for truly autonomous agents that can adapt to new information and changing environments without a person holding their hand the whole time. It takes principles once used for simple robots and applies them to the incredibly complex world of language.
And that leaves us with a pretty mind-bending final thought. For years now, we've used AI to find answers for us. This research points toward a future where AI might have the curiosity to seek out knowledge for itself. So what becomes possible when AI stops just answering our questions and starts asking its own?